Right, hello everyone. I just wanted to go through a couple of things to help you with some revision for the exam on Thursday. This is what you can see on the screen here is chapter 3 or topic area 3 from the revision guide, which is available on the Google site. There's a link to that from the Google Classroom. And most of this is covered in the R039 coursework, where you've been doing the fusion drawings and the hand drawings as well. But there's a couple of important parts of it I just wanted to really highlight so you know exactly what you need to remember. So make sure you have a read through this. There are some questions in this revision guide section as well. You need to know some of the basic features of the different types of drawing. So the freehand sketching to get across initial ideas. They're not drawn to scale. They're not accurate design drawings. They're just rough drawings to show the overall kind of shape or the overall appearance of something. The isometric drawings, that's a bit more precise. So an isometric drawing is drawn at a 30-degree angle to the horizontal, and that's something you need to remember, as opposed to the oblique drawings, which are drawn at 45 degrees from the horizontal. But you've got this kind of 2D sort of starting sort of point, and then you have the lines going back outwards at 45 degrees. The orthographic drawing, that's one of the ones you've been producing for the 39 coursework, the R039. You have your isometric view in the top right-hand corner, and then you've got the top view, the front view, and the side view. We've been calling that the third angle as well. So those are orthographic drawings. Your exploded views, just showing all of the components, all of the parts of a product exploded outwards so you can see everything there and how it all fits together. And then a particular type of exploded view is the assembly drawing. Again, this is what you've been doing for the R039 coursework. So it's an exploded view in isometric. So you've got that 30-degree angle between the horizontal and the actual the alignment of the product. So that angle, I don't know if you can see my mouse pointer on here, but it's 30 degrees between the horizontal and the edge of that kind of I'm not quite sure what that object is, but that product there. Block diagrams, just showing how things kind of fit together, how things work. So this is how a light might work with a bell as well. Flowcharts you've used. So it's another, this section, this topic area is all about how you might present design ideas. So you've got the different types of drawing, but you've also got how you might sort of present a process. So most of you, nearly all of you, so I've been going through the R040 this afternoon as I'm recording this, have got those flowcharts for your planning for the lamp making in R040. Circuit diagrams you would have seen in your physics lessons. Circuit diagrams are showing how different electrical things are connected together, as opposed to the wiring diagrams, which are not necessarily using standard circuit symbols, but they're showing how to connect stuff up. So that symbol there, where it's the headlight, is not a traditional circuit symbol for a light or a lamp, but it is showing quite nicely how you might connect that up in, for example, a real car. Now there's a couple of details you need to remember, and it is just a memory thing, so it's worth having a look at this table for the advantages and disadvantages of the different drawings. You can probably figure out all those advantages and disadvantages. Some of them are really just common sense things, but what isn't common sense, and you do need to remember, are these questions are worth doing. But what you do need to remember is some of the standard kind of symbols for things. The third angle orthographic, hopefully you know quite well. The units are in millimeters. The tolerance is how close to an actual value your product would need to be. And we've talked about this in class a little bit. So if you're making something very precise, like a part for a jet engine, the tolerance would have to be very small. So the product has to be made to a very, very, very precise, small tolerance. It's got to be close to an actual value. Whereas if you're making something like, I don't know, fence posts, there could be a lot more scope for having a bit of spread in the size and the length of those posts. So dimensions are marked on the diagrams, on the drawings in that way with those arrows, with an arrow at each end of the line. If you're drawing a circle or an arc, you record the radius, and the R in front of the number there shows you that it's the radius. If you're drawing a diameter, you have that kind of a circle with a line going through it. So it's those symbols there and there. So that's quite a good example where you've got both the diameter and you've got a radius. Now this is where it gets really kind of really quite detailed, and this is something you just need to know. I think this is quite unlikely to come up in the exam, but just so you know, this might be a way of representing the surface finish on something. So if you've got, for example, a metal surface, you might use these symbols to kind of get across how you want the finish to look. So we just need to know these three things and what they represent. So that's our basic surface finish symbol. If you've got the tick, but with the top of the tick with the horizontal line going across, that means it must be a machined finish. And if you've got a circle inside, you can't take anything away from that surface. And then you might kind of mark on there different kind of machines and different techniques you might use to do that. Now these different lines you've probably again seen on Fusion, but you may not have even thought much about them. So the thick lines are the outlines of the product. And if there are lines which are either there to help you draw the thing, or they are lines for the other side of the product, which you wouldn't normally be able to see if you're looking at that as a real thing or a photograph. So they're almost kind of like lines which, if you imagine the thing you're looking at is transparent, you can see like the back of it. Those lines be drawn thin. Dimensions have arrows in each end. Hidden details, so hidden edges, things which might not be immediately obvious on the drawing, you have with a dash line. If you want to draw lines to show where the centers of different things are, so where the center of a plane or something on your drawing is, you have this kind of mix of a dash dot line. And if there are breaks in the object, you have these kind of zigzags. If you're annotating things and you're pointing to the edge of something, you have an arrow on the end. If you're pointing to somewhere on the face, then you have a dot on the end. If you are drawing a line where you want to highlight several edges, you use these kind of, they call them ticks, but these kind of sort of slashes across the line. If you want to mark on a dimension, but you don't want to actually write it over the double arrow, you can have these kind of slightly angled, then horizontal lines to put the dimensions on. And a couple of abbreviations. So if you're measuring, for example, the diameter of something like a bolt, you would call this across flats, and it's measuring across those shapes. So it's the width between two parallel surfaces. So it's kind of, it would make more sense if it was from that parallel surface to that parallel surface, and that would be represented by writing AF and then the measurement. A center line, CL, showing where the center of a hole is. Diameter, so the diameter is abbreviated to DIA. So if you're writing about that diameter in a drawing, you would use DIA. But if you're given the size of the diameter, you'd have that circle with the line going through it. If you're referring to a drawing in a third angle projection, for example, this will be the box which appears in the bottom right hand corner. Drawing is DRG, just a bit of a lazy way of writing drawing. MAT for material, again just shorthand for material. A square, if you've got something which is square in your drawing, you could write SQ. And if you want the dimensions of the square, you'd write, well, you have the symbol for a square and then the size. And then a couple of extra little things. So these are, again, I think they're really unlikely to come up. So you've got a couple of symbols. So if you've got this circle, then like a double circle, it would represent this kind of cutaway sort of chamfer there. You could represent holes with a circle and a dash line. And this kind of thing, if you imagine, this is knurling, if you had a bottle lid, so imagine the lid of a Coke bottle, it's got those kind of sort of grooves in the lid, that would be straight knurling. And sometimes if you've got a metal dial, if you have something like a volume control or something like that, you can have these kind of diamond shapes cut into it. That would be diamond knurling.